Today I came across Mina's podcast on Lex Friedman talking about rapid testing and about solutions to the COVID-19 crisis. It also points out the one problem that I have with vaccines, and probably the main reason I didn't invest in Moderna. I issued a response yesterday to my reluctance to invest in Moderna. I think Moderna is a great company. I think there are real reasons to invest, but there's also a concern, and Mina is pointing that out in this podcast. This is a Not Even Wrong podcast. It's December 19th, 2020. Today is a Saturday. There's no update, so let me just get right into the subject. Yesterday, I spoke about Moderna. Moderna is a company that fits very well into our mission statement, which is to generate wealth by investing in fundamentally new concepts and engineering practices with large impact. Moderna is a fundamentally new concept, and it is an engineering company. So I think in that, and it has potentially very, very large impact. What Moderna does is it reprograms, it uses code, it uses mRNA, which is the code that programs ribosomes in mammalian cells, i.e. in human cells, to do stuff. So what they do is they send a particular message called mRNA, message RNA, to our cells. That message encodes ribosomes. They create a protein, an antigen, which would normally be created by the virus. In this case, there's no virus, but the protein, the specific coronavirus protein, gets still produced. It's completely unharmful, but it does trigger an antibody response. That means our immune system recognizes those antigens and starts creating a response, and this is what the vaccine is supposed to do. So this idea can be translated to many other applications. What we like about Moderna is the idea that they build a platform, that they are massively parallel in their approaches. So what works for liver can work for heart. For example, they have a hard tissue regeneration mRNA, so they send mRNA directly into the heart or close to the heart, triggering the cells around the heart to produce certain proteins which reinforce tissue. That can be very helpful in case of heart attacks and things like that. It could be used for kidney regeneration, and well, you can see where this is going. We could have skin regeneration, hair regeneration, God knows what. So there's a lot of potential here. The company is built on a platform. It's built as a software, as a cloud-based software or algorithmic type of solution machine for diseases. And it's also using code, mRNA, to trigger responses in our cells. So our cells are creating the medicine based on a code sent to them, and that's what Moderna does. According to Stefan Bancel, the CEO, Moderna is really an mRNA delivery company. So they deliver nucleotides, which is mRNA, is a bunch of nucleotides, a bunch of digits, if you want, organic digits, the zeros and ones of nature, which are nucleotides. They deliver them to cells. So the delivery mechanism is really one of the challenges. How do you deliver that message uninterrupted, uncorrupted, to the right place? This is the key competitive advantage of Moderna. Now, if we take a big picture approach here, this company fits many applications or many approaches that we discussed in the Innovator's Dilemma, that we discussed in the Innovation Stack. This company is building an innovation stack from scratch, delivering solutions to hitherto not solved problems or very, very difficult solved problems. That means very expensively solved problems. This is a much lower cost, more efficiency, high throughput, high repeatability type solutions. This is engineering meets biology at its best. So this was the case for Moderna, and we are absolutely happy to invest in Moderna. Now, what Mina says in this podcast is unfortunately a rebuttal a little bit. He says that instead of going for the big vaccine solution that we went for, which is a good thing, he's not against that, but we should have had rapid testing and at-scale rapid testing available. He says this technology is available, low-cost rapid testing. So instead of having lockdowns and big pharma solutions, we could have had freedom and dignity preserving solution, which is we could have just have rapid testing. You can test yourself all the time. It's like a pregnancy test. You can then decide, of course, if you're positive or negative, what to do. But let's assume most people would do the right thing and are incentivized to test because they have to test in order to go to work, in order to socialize. We could have kept a lot of things open. Certain socializing aspects maybe should be at least banned for a while, such as big stadiums and stuff. But there's a lot of occasions where I think rapid testing could help at least keep the arteries of the economy open much, much wider than they are today. And also, I think from my perspective, the dignity preserving aspect of not having to wear masks all the time and be feeling this almost George Orwell type big brothers watching you, and God forbid if you do something wrong type of feeling, that could be relieved a bit. If you test negative, you are not contagious. What Mina points out is that these tests are very good at actually testing contagiousy and not necessarily infection. Who cares if you're infected if you're not contagious? And this is the key. So a long story short, but Mina also alludes to, and he's a Harvard professor, he is consulting with politicians and CEOs all the time. He even spoke with Elon Musk about this. We need an engineering solution. We need engineer. Public health is an engineering problem. It's not a conceptual scientific problem. And I think what he's saying is that public health was hijacked by the scientific community into a scientific realm. And then when it's a scientific realm, it is, in David Deutsch's words, a bad problem to be solved. For example, the formulation of, well, how can we make sure nobody gets infected with coronavirus is a bad problem. The solutions are bad too. Lockdown and things like that are not good solutions. A much better solution would be an engineering solution. And one example is low cost, at scale, massive, rapid testing, which then allows functional, practical behavior of people. And if we can bring the R naught down to below 1, which is the infection rate, if you're infected, how many other people do you infect? If you had this test, the chance that it goes below 1 is very high. And once it's below 1, then it's logarithmic or even less. The growth is not exponential, and therefore we can contain the virus. The less people are infected and have the potential to infect others, the less the virus can spread, and we can beat that thing. So Mina said something unbelievably important. He said he would like to start a chair at MIT, public health engineering, because he thinks public health is an engineering problem. And I've never thought about it this way, but if you think about it, a lot of the public health issues that we have are really engineering problems, not health science problems. There is a place for science. What Moderna is doing is great. And some of the problems they're solving, like cancer, diabetes, and all these types of things, they have a scientific angle to it. But often the solution is actually engineering. We discussed this so many times in Silicon Valley. You could reduce the diabetes cases, even the cancer cases, just by changing behavior. This is an engineering problem, maybe a social engineering problem, but it's still an engineering problem. Mina talks about real engineering, meaning technological advancement, new concepts, new engineering practices in, let's say, pandemic fighting, which is low cost, at scale, rapid testing, behavioral changes. So the same way we brush our teeth every day, we could just do a test once or twice a day. What's the big deal? If it costs me less than $1, I'm happy to do it. I pay $3 for a coffee maybe once or twice a day. I don't mind paying $1 or $2 for a test that gives me the confidence that I am not infectious, that I can protect people around me, and also gives me the freedom to go around. I am the kind of person, I don't like to be told what to do. I am absolutely conscious of other people. I try to stay away from people. When I walk on the street, I try to do all the distancing. This is all fine. I don't mind. But I am very sad for many businesses, including the businesses that I like, coffee shops and things like that, that I can't visit. And I think if we had rapid testing, we could open up a lot more of that stuff and still not have contagious situations. And I think right now, in particular, where we are at this point, Mina points out that the vaccine is a good thing, but unfortunately, we also have a lot of people dying in hospitals because we were waiting too long. So this is a real cost. This is not just some philosophical conversation. We need engineering solutions. Now, why am I pointing all this out in this particular episode? I spoke about Moderna yesterday, and I feel like what Moderna is doing is great. I think they did almost the right thing for the wrong reasons. So what their mRNA approach does, I think, is phenomenal, and it should be applied. And I think, again, we are happy to invest in the company because it is using fundamentally new concepts and engineering practices to have large impact and generate wealth. However, we believe that in the COVID-19 crisis, other solutions such as rapid testing and the social responsibility around rapid testing would have been a much better approach than the big pharma approach. Big pharma is a big dollar. The big pharma is an industrial complex, very similar to the military industrial complex. And the downside of the military industrial complex is the same like in the biotech space or in the pharma space. It is they want to have big money solutions. I've spoken about this after the book discussion of Skunk Works. Skunk Works is supposed to be a book about heroic engineering achievements of the US Air Force and the engineers working on airplanes. In fact, the book is a testimony of failure, of egos, of corruption, of doing the wrong thing, throwing money at stuff and not getting stuff done. Look at what SpaceX is doing. Look at what startups can do with much, much less budgets because they have an incentive to deliver solutions, versus Skunkworks did never have an incentive to actually deliver solutions. Skunkworks' main incentive was to do big stuff, big money, big budget, all that stuff. The same is applied to big pharma industrial complex. We want the big stuff, the big solutions, the billion-dollar drugs. We're not interested in 50 cents rapid testing solutions, engineering in social and technological engineering solutions for public health. That is not glorifying. That is not bringing you medals and Time Magazine Person of the Year type awards. Unfortunately, the incentive structure is such, and we are losing wars the same way our army, our Air Force and Navy are losing wars against guerrilla tactics and terrorists because they're not set up to win those types of wars. The big stuff, the big tanks, the big airplane, missile, all that stuff, defense mechanisms, attack mechanisms, they're good for certain things, but they're not very good to fight very particular wars. We need much more piecemeal, step-by-step engineering type solutions to fight those wars. We can do it. We have the know-how, we have the incentive, we have the capabilities and the people and everything, but we're not set up to do it. And the same way in the Bio-Pharma healthcare complex, the Bio-Pharma healthcare industrial complex is set up for big billion-dollar massive data collection. The FDA is set up in a sense that they need a lot of data, a lot of security, because their mandate is not to fail. It's very difficult not to fail when you deal with biology. So there's another problem right there, which is, well, how can you be a regulatory body when you always get pointed at if things go wrong and never get the claim if things go right? It's very difficult. So my conclusion here, based on Michael Mina's comments, is that I think COVID-19 has shown that our biopharma healthcare industrial complex is not set up well for challenges such as COVID-19. In general, it's not set up well to deal with any kind of challenge. So we don't have a public health system working because we don't allow for public health to really thrive. What we're doing is we're hijacking public health problems and disguising them within problems that help the biopharmaceutical and healthcare industrial complex. But those are often scientific solutions. They're big business, big scientific solutions. They're fine. They get Nobel Prizes and all that, but they don't actually solve everyday life type problems. Very often they don't. And this is a very good example, and that was the reason why we were also skeptical about Moderna. Now, as a conclusion, we think that this problem is not necessarily Moderna's problem. We think that the company is operating within the system as it is. We don't think the system will change anytime soon. We think that the scientific achievements of Moderna are still very laudable. We think that the company is built around an engineering concept and has actually as an aim to lower the cost and increase scalability of solutions. So within that context, they are actually a disruptor, even though they're also riding on the gravy train of this big industrial complex. Nevertheless, we would think that the company has the ability to thrive in a more efficient, less wasteful system in the future. Thank you.